Welcome everyone to another Observability Clinic. Today's topic is GraphQL and OpenTelemetry. Observe, diagnose, and optimize. Today with me, I have Justin Scherer, Senior Engineer at Northwestern Mutual. Hey, Justin, thank you so much for being here.
Yeah, thank you for inviting me onto this clinic.
Yeah, definitely. I mean, we've been talking about GraphQL a little bit back and forth. I think we will also share later on a link to a podcast we've recorded. You've presented that Dynatrace Perform, and we've done a couple of things together. And really, what I would love for you to do now to enlighten us a little bit about instrumenting GraphQL, which I know a lot of people are using out there, using OpenTelemetry, and then best practices on what patterns are out there, how to observe, how to diagnose, and how to optimize. And without saying any further word, I would just want to pass it over to you and see what you have prepared for us today.
Yeah, absolutely. Hey everyone, I'm Justin. I'm a senior engineer at Northwestern Mutual. Just a little background, Northwestern Mutual financial services company. We use GraphQL extensively inside of Northwestern Mutual's kind of tech architecture. And there have been a lot of pain points when we were going through it, and through us kind of deep diving into both GraphQL and then finding ways that we could look even further into our GraphQL usage through the use of OpenTelemetry, we've kind of been able to break apart and demystify a lot of these issues, and also just kind of like common assumptions that GraphQL provides.
Mm-hmm.
So kind of going over that, what we learned and now passing that along is kind of what is the introduction into GraphQL? Is it this brand new magical system, or is it just kind of an add-on to something you've kind of maybe already used?
Mm-hmm.
And with that, the issues that get associated with that, there's quite a few issues. And if you're not familiar enough with the technology, it can seem like a silver bullet, but it can end up being one of the biggest pain points that you may ever have in your system. And a lot of that can be diagnosed through the use of OpenTelemetry. But GraphQL, again, can be this kind of black box system. You think of ORMs, and we'll bring that up in a little bit. But you have your Hibernate, and you look at it, and you kind of just put some stuff there, and it just magically works. But for those that have used Hibernate, they probably also know when it goes wrong. And when Hibernate goes wrong, it's never a simple issue. It usually is a cascading failure.
Yeah, and I think you phrased this really well. The black box is sometimes really great because the black box is doing something, and you sometimes don't question how it is doing the things. But if you actually get insights into what's happening within the black box, and you see it's actually not very efficient in what it's doing, then you can optimize things. But in order to optimize, we need to get the visibility into the black box. And your correlation or your kind of reference to Hibernate, I know we talked about this also in the podcast, is just spot on. But yeah, I'm now curious. GraphQL, so many things to learn. So go ahead.
Yeah. GraphQL. So just kind of overviewing the technology. Maybe you're someone that already uses GraphQL, but you kind of haven't really dived deep into it. There's still kind of a little bit of mystery, especially if you use one of these out of the box kits that you get. You don't kind of build your server, but it just kind of hands it to you. You may not understand really what it's doing. And for others, you may just be wondering what GraphQL is. And then there's probably the other camp that you've had tech leadership that says, hey, we want to adopt this brand new system. It's all over the web. And so we want you to actually look into it. And so you're kind of diving into this and being like, well, what are the gotchas? What are the pitfalls? And what are ways that I can potentially alleviate concerns that my dev team may have that maybe has not been looked at? So the first one is you query your endpoints for what you want. For those that have been around for quite a while, you probably remember SOAP. SOAP was this kind of the first foray of this client server architecture without thick clients anymore. They were still there around, but early web clients, and you really were able to pass information back and forth. Sometimes it was on single endpoints, sometimes it wasn't, but you pass a lot of information, and you pass capabilities and all this stuff. And that's really what GraphQL kind of reiterates again. It does this kind of idea of, hey, You want to do something, you tell me what you want and I'll go do it. You're not going to go to different endpoints or anything like that. You're just going to ask and you will receive what you ask for. I kind of hinted at this, but everything is usually on a single endpoint. Usually this /GraphQL route, it kind of separates the idea of you may have a service that you've mixed both REST and GraphQL on. And because of that, you will put everything on a singular route. For those that are already like starting to see where maybe issues are cropping up from this. There's also this kind of issue of single verb and status code. You should be doing everything on a post. That some will say, well, you can do GET requests. That's usually not preferred. There's a multitude of reasons. So there's already your first hint that you should put everything on a post. If you're using the GETs, try to migrate over. And then everything should return a 200. This is, again, one of those things where you're probably like, well, no, I have a 401. Someone's not authenticated, right? Well, you most likely still want that on your 200 because you actually put your errors into the return object. This is kind of that idea of a client now no longer needs to worry about verbs. They no longer need to worry about endpoints. They no longer need to worry about status code. They get everything from a single endpoint and they get everything it should always return. This is kind of this overall philosophy of GraphQL is a very client-focused idea. And if you want more information about GraphQL, I really did this high level. I didn't go into things like queries and mutations and subscriptions, all of the other fun stuff that can come with this. But you can go to the main site, the graphql.org, and you can even look at the specification. I will say, as someone that reads a lot of specifications, someone that even read the PDF specification, I don't know why I did that, but I did. This is a very easy specification to read, and it makes a lot of sense. I would also consider it not dry, which is very interesting that a specification is not. So all of that, it's really great from your client side. Your client is like, I don't need to worry about routes. I don't need to worry about handling status codes or switching services, all of these ideas. I don't need to worry about that anymore. That's great. But as a server implementer, you're probably seeing all that and thinking, that looks absolutely horrible. And without the right tooling, it can be a problem. When you're getting above a simple service, and you'll always see these, either it's a Star Wars example or a library example out there for GraphQL, you start getting into more complicated projects, usually what an enterprise is going to do. These are the issues. There are a multitude of issues that start cropping up. The first that I like to go over is the N+1 problem. So this is very similar to database ORMs like Hibernate, Entity Framework, the multitude that are out there. And what this ends up happening is what you think is maybe just a single query coming in, it actually can spawn into 100 queries. It could spawn 1,000 database connections because it's not all tied together. It basically, what started off as this great, oh, I only did this one thing that your client sees, from your server side, it just turned into a massive, it can turn into a massive DOS attack on your own system. Everything is on a single endpoint. It makes it hard to see what queries, what mutations, what is the behavior someone's asking for. Again, your client is going, well, this is great. I only have to do this single behavior, but your server implementers are thinking, well, shoot, everything comes in on this one endpoint. I can't tie functions, behavior to endpoints anymore. I now need to go and start piecing together a request body and see what was in there and what the behavior actually occurred. And this just kind of goes into the third point. Observability is near impossible. Anyone that's used things like Jaeger, Prometheus, any observability tool, they know a lot of that behavior gets tied to REST, because REST has this wonderful way of, when you're tracing between services or you're looking at flows, you're very able to see a single REST endpoint that talks to a single method that talks to this, let's just say, a single database query. No, I'm oversimplifying it a bit, but there's a nice linear flow that's usually you're able to see. With GraphQL, that's gone.
Mhm.
You see everything always coming into this single endpoint, and then it does this giant fan out issue, and you can't really tie it to much. You can't tie it. Was it GraphQL that was the problem? Is it my own method that's the problem? Is it a further service down the line that's a problem? I don't know. I'm now a bottleneck in observing the behavior. There's another fun issue that you get into, and that's this idea of a stitching or using gateways. So everyone's should be sort of be familiar, or at least kind of understands how maybe an API gateway works, be it Tyke, be it API gateway through AWS, any of those, where it looks like everything comes in and then does that similar fan out, right? But it goes to separate services and the further behavior. With GraphQL, the base level specification doesn't have it, but there is this idea of bringing a bunch of those, what are known as schemas, together into a singular service, and then it does that behavior. So now you're starting to see an even bigger issue. What may have been a single GraphQL endpoint that maybe calls multiple microservices, so you could kind of see that behavior. Now you're going to have a stitcher or a gateway in front of everything that calls a singular endpoint that then starts spawning multiple requests to other GraphQL services.
Mhm.
And so this problem just gets even more compounded in the observability, N+1, everything. It just gets even more complicated. And there's finally this idea of a client can ask for what they want. So in a query, you can say, hey, I want X, Y, and Z fields. But maybe the server doesn't support that Y field. So the client does still need to know what the server is capable of. It's not just this fire and maybe it will resolve some of those fields, maybe it won't. Well, no, if you ask for something and that schema doesn't see it, it will throw an error back to you.
Mhm.
And it will say, no, you asked for something that's just flat out not here. Does this make sense?
It does, and it's
Yeah.
just an unfortunate reminder of many things we have done and troubleshooted in the past. I mean, you bring up Hibernate. Here's an example. You also mentioned the entity framework. I think the question always is, it's the balance between convenience as a client and actually then the complexity behind the scenes that it can allude to. One quick question. I know you come to the solutions in a second, how we can tackle these problems. I just recently did a session on making calls to the OpenAI, to ChatGPT's API. And what I thought was interesting there, the API actually returns kind of, I think it's called tokens. That means the complexity of the request that came in and how much you actually, are charged for it. Is anything of this in the spec for GraphQL? Meaning if I make a request to GraphQL, is GraphQL in the end also responding in some way how complex that query was to resolve?
No, that is nowhere in the specification. There are systems that do that. Two that come to mind. One we'll talk about. I'll give a little oversight, which is Apollo's Apollo Studio, and then the Apollo Supergraph. They do that. And then what's called the Guild, the Hive product, they do that. But in
Okay.
any base implementation, no, it's just not
Okay.
there.
Yeah.
Yeah,
Cool.
it's really nice. That would be
It
absolutely
would be,
wonderful.
because then as a user, as the client of this API, right, of GraphQL API, you would get as a result not only, hey, I get the result, but I know this was really expensive, and so maybe I can then also adapt the way I query if I don't have the luxury of getting the observability that you're actually showing us, I think, in the next couple of slides, yeah, of what's
Yeah.
possible, yeah.
So yeah, really, I mean, diving into it, well, there are solutions to everything that I kind of brought up before. I kind of go over the big three here. The other ones, they're either a compound of one of these specific issues, and then the specific tooling that's in here actually solves for it. Or number two, it really comes down to custom work. And the one I'll specifically throw out is that kind of client needs to know what the server has. That is still a problem that is not a very easy solution. And there's not a lot of tooling out there for it. There are ways of like generating your client queries for them through your server or giving like specific specifications to your client. But then you can also then ask the question, well, if I'm doing that, isn't that just REST again? So that's where I kind of bring up like that one's a very specific problem that I don't think there's a right now ready-made solution that's either one, not just making GraphQL turn into something else, or number two, it's just still kind of open-ended and it's still kind of this open problem that's out there. So yeah, really diving into it, we have the N+1 problem. And the solution is this idea of a data loader. And really what that's doing is a data loader in the JavaScript world, it looks during the event tick when requests are coming in and it goes, oh, I noticed this X request is the exact same as this one, and this one's kind of like this one. And it basically starts meshing all of that together to make sure that when a resolver runs, it actually just feeds in for all of those instead of it running that resolver over and over and over again for everything that came in. Yeah, that was an early problem that was found. The second one, stitching or gateway issues. I kind of hinted at this. There's a very famous article out there from Netflix that talks about how they built their own stitcher and they use GraphQL, except for they sort of released the code, but they didn't really release too much about it. And so it left this kind of like hole in the market, and it did get filled. There are two big toolings hinted at before. So there's this idea of stitching. The Guild created the mesh, which allows you to not only put together separate graphs, but also turn graphs from other data sources. So things like if you have a microservice that has a bunch of REST endpoints, it can actually look at that and convert it to GraphQL and bring it into the mesh. And then if you don't like the stitching way of things, you can go over to what's called Federation, and Apollo and their Apollo server is just an absolutely fantastic tooling. It is proprietary, but there are open source components of it that you can do yourself. And it's just, there's kind of those two ecosystems that are sitting out there. And so I would say either one fits the bill. And it's really just, I would say, your way of thinking about your graphs and how you want to think about your graphs. And then finally, the big one that we're kind of going to work into today is observability. And this is where I really found OpenTelemetry was through this. And OpenTelemetry kind of brought 90% of the issues that we were seeing in our GraphQL systems and just brought them to light instantly. And that was really from that plugins were already created for us. And that we'll talk about it, but the specification and even the way you build out tooling is, I would say, super intuitive to where we were actually hinting in the future, but we were able to build our own custom stuff to then where we still wanted more observability. And really in that regard, you brought it up, but we had a great podcast on unlocking the power of OpenTelemetry, and really where GraphQL was the start for NM, we really have dived into OpenTelemetry and trying to pull as much value out of it as possible. So I've QR code sitting there for anyone that wants to listen into that. I think it was a wonderful discussion.
Yeah, especially coming from you as the guest who has not only implemented OpenTelemetry, but also we talked a little bit about how to scale OpenTelemetry then in an organization and really what it does, what kind of gaps it fills. So you can listen to this on any type of podcast app that you use, and we'll also make sure to put the link to the podcast into the description of this video, either on YouTube, if you watch this on YouTube, or on Dynatrace University.
Awesome. All right, so we're going to really start diving into that final piece of this. And really what I should bring up is the other problems also start to be unraveled a little bit with the use of OpenTelemetry. And that's really why we are focusing on the OpenTelemetry piece. It can highlight N+1 problems. Maybe you brought data loader in, but all of a sudden a N+1 problem is still occurring. You can now see that with the OpenTelemetry ecosystem. You have a stitcher or a federator, but you didn't use, let's say, one of the paid for products. You want to still get your organization into it first. And you can get the value that those give you by implementing OpenTelemetry. All of those situations start coming to light through this. And that's the reason why I think highlighting OpenTelemetry and the capabilities it has is great. And so really what we're looking at here is a TypeScript example, so JavaScript, of how do I instrument? So really what you're doing is you're bringing in the Node SDK, you're bringing in a bunch of your instrumentations. Here I'm bringing in 4, so an HTTP instrumenter. So any outgoing, incoming calls, I can instantly get the information around it. Express instrumentation, we run Express server. So now we have our Express GraphQL, the highlight here. And then even AWS, we're bringing in to see how our AWS SDK usage is. And then finally, you bring in a sampler. A sampler is this idea of, hey, when requests are coming in or when any of these instrumentations are being hit, when do you actually want to create a trace and you want to keep shipping it off? And there's many different types of samplers. In our use case here, we're going to use the always on sampler. That means every single request that comes in, we are going to sample it, we're going to create traces, and we're going to ship it off. But there's even things like random. There's ways of looking at response times and then seeing, oh, it was a high response time, ship it off. All up to you. I like to have as much data as possible, so that's why I have the always on sampler on. And then in here, you also see this trace exporter. This is the actual, hey, where do you want to export your traces to? So in this first case, I'm saying, hey, if I'm on my local machine, I don't want to try exporting to my observability platform. I want to just export it to the console so I can just see it. I kind of hid away what our observability platform is, but this is where you basically say, hey, I want to ship it to Jaeger. I want to ship it to Dynatrace. I want to ship it to anything, right? And then finally, on the instantiation of this Node SDK, you bring in all of your instrumentation. So here, again, everything that I imported above, I'm bringing in. And then finally on that GraphQL one, there's a few options here. So merge items, what this is saying is, if I have a bunch of similar items in my system, I don't want you to spell that out in my trace. I want you to just bring all of that together. A lot of the times we do this because we are tracing very low-level fields, and so we want to not necessarily have traces for all of those. We just want to group them and see, is there any kind of outlying behavior? A depth. So here we have -1. This is saying, don't worry about the depth of a GraphQL query, just let it come through. But if I set that to 1, that would only allow the top-level fields to be instrumented by GraphQL. So this allows it, GraphQL can add the instrumentation can add a tiny bit of overhead. And so if you have a super deep query, you may not want to run the full gamut of that query. You may just want the top 2 or 3 fields because that's what you know is going to be your problem areas. And then finally, there's this allow values flag. This is in the case of, hey, do you actually want to see what this specific field resolved to? And for some people, they might want to go, well, cool, I can now look at this and actually see, did this run properly? Did I get a correct value out of this? Or did it somehow mess up? In our case, since we are a financial institution, we need to hide PII, PHI. And so this allows us to say, nope, don't show values, just ship off. And then we export it. And all you need to do from there is import the SDK at the top of your top level file, and boom, you're instrumented. You're done.
That is really sweet. So that means as a developer, if I have an app that is using GraphQL, then the only thing I really have to do is configure the SDK, and then in my individual code files, I just import it. And from that point on, the automated GraphQL instrumentation kicks in and gives me OpenTelemetry traces.
Absolutely.
Wow.
It's kind of seamless in that regard. I will highlight one specific caveat with this. If you are on native ESM, for those that are in the Node universe, you know what I'm talking about, but this currently will not work. The way a lot of this instrumentation actually works is it surrounds the library with some code, and that's how it's able to basically start reacting to it. With native ESM, it basically doesn't allow you to look at the libraries that have been loaded in. There is current work in the OpenTelemetry group to actually be able to inject in on native ESM. I think there was one request that was just merged, so you can actually test it out. But that whole API is in flux in terms of the Node side of it. Node has already stated that the way they're allowing you to look at libraries and how they're loaded in, that's being still reworked at the moment. So obviously use if you want, but if not, and you want this capability and you're on native ESM, feel free to just transpile to CommonJS. Something that will still give you all the capabilities you want in your code, but then at the runtime, you'll then also get your observability capabilities. All right. The big question that's probably going to come up: what if my language is not JavaScript? I know I focus on the JavaScript side of things, but that's fine. Almost every major language has a GraphQL OpenTelemetry plugin. The ones I specifically know are C#, Go, and Java alongside JavaScript. Actually, no, I also know Rust because I've personally used the Juniper plugin. So those are the ones I personally know. But if all of those have it, that means that most of the other ones are going to have it. It's a very, since GraphQL has become this kind of giant ecosystem, a lot of other languages have brought in their OpenTelemetry plugins and have brought in the GraphQL piece of it. And if not, you can always hook into the OpenTelemetry yourself. I mean, every one of these languages I'm showing you, they have their own SDK. Just because there isn't a ready-made plugin doesn't mean you can't just write to the SDK yourself. And going to the OpenTelemetry docs there for instrumentation, that'll show you how to do it. I can say it is quite easy. It is not something that is too difficult compared to potentially building something yourself for another library or implementation. So all that sounds great. I kind of show tracing, right? That's one side of observability. You talk to really any observability expert, and you know there was the big three for the longest time. I would even say there was a big two for the longest time, and that was tracing and metrics. And then, you know, in the past, I would say 5-6 years, right, we got the logs where we're like, yeah, that's part of our observability system. That's part of our entire package. And now there's even more, right? They're bringing out real user monitoring. They're bringing out code profiling. All of this is getting wrapped into observability. And that's good news because OpenTelemetry is doing exactly that. They are openly specifying a protocol for all of these observability touch points. Some are more mature currently than others, but they're all getting built. And so what I'm showing here is actually a custom metric plugin. And so here, what I'm doing is I'm using what's called the proxy API in JavaScript, and I'm bringing in a resolver. So for every query or every piece of code where I can't just simply look at an object property and bring it in, I have to write what's called a resolver. So for every resolver I write, I'm looking at the function itself, and I'm saying, hey, what's the field name of that thing? And if it's already in this, I just increment the usage by 1. Otherwise, I just add it into this map and say, hey, here's 1. And then I let the function run. And so what I've basically done here is I'm now tracking every resolver that has been run and tying it to both my queries and mutations. And this is almost as simple as it is to build custom metrics. Again, this is TypeScript, JavaScript, but it should start to showcase how simple it can be to write your own custom behavior that you may need. In this case, we're mimicking a feature of something that's in both Apollo and the Guild's tooling. We're just doing it so that way we can integrate it into our observability platform. So, quick demo. So here, this is, for those that know, this is Dynatrace. And what we've basically been able to do is, here you're starting to see this right here, rollout info query. And this is interesting because for those that have used, again, Dynatrace or even other observability platforms, this would be called the route endpoint. And so you actually even see it up here. You see this V2 GraphQL. But because we now have information from OpenTelemetry, I'm able to name my actual touch points based off those names. So what would have been a whole list of traces that were called V2 GraphQL are now actually named after the query that's currently being run. So I already, solved one problem that we brought up in the beginning. And here, anything with this telescope icon, you're seeing is OpenTelemetry adding the information that I wanted. And so here, this is middleware. So we have a query middleware that's being run. Just trying to load up the info right now. But this came through because I added that express instrumentation, express init middleware, cores middleware, cookie parser, and then a bunch of anonymous functions are all in here because I added that one instrumentation. From there, I'm seeing then GraphQL. So anything here that's GraphQL.parse, validate, execute down the line, this is all done because I did that one instrumentation of GraphQL. And then over here on the right, you're starting to see attributes. So I have the field name, as I said above, was able to name it. That's because we have this down here. And then I'm even able to see the query that someone asked for. So some of you may have been thinking, well, cool, I can now see the query, but what did they actually ask for? And I can actually come in here and see, oh, they ran this rollout info and they got all of this information. This is specifically what they asked for. So if they didn't ask for status, this wouldn't have been here. So I now get all of that information. And then you see this HTTPS post. This is me because of adding in that HTTP instrumentation. I'm now getting that. And so what you're seeing is by that minimal amount of instrumentation, I'm now getting all of this information and all of this benefit added in. And now I'm able to see, hey, is this query acting normal? Is there a resolver specifically in this that's acting weird? Is validate being weird? Should turn this off because now you're also even seeing the timing of everything that just ran. And this is where you start deconstructing, right?
Yeah. And Justin, for me, this is just, I've looked at so many distributed traces over my lifetime. So for me and for others, maybe this is normal to see what we're looking at here. But if you scroll up again, all the way to the top, what we really see here is as one individual request that initially came in, it seems on Nginx that you used there on the V2 GraphQL endpoint. It seems it was actually using Tyke here as an API gateway. So that's the API gateway that is then taking that request, passing it on. Then what's really interesting, what you say with the middleware, right? You basically see what is actually happening within your client, within GraphQL as it is parsing the query, because maybe I assume some queries might be harder to parse than others. So maybe you even have a performance impact here on the type of query and how tough it is to actually parse it. And then as you scroll further down, you see how long it actually takes GraphQL then to execute the requests to the backend system, to your microservices, to pull in the data and then aggregate it up again to ship it back to the caller.
Exactly. And you brought up a very good point. We've actually ran into, on some of our very complicated queries, the biggest impact we've actually had is on this validation step. Something I didn't mention, but can easily be talked about. There is validation. So there are actual types built into GraphQL. And because of that, at runtime, there are ways of turning it off. It's not recommended, but it will actually, on the incoming and on the outgoing, GraphQL validates all of that. And so if you're asking, let's say for 3,000 fields, all 3,000 of those fields and the specific element that you're asking for needs to be validated against the GraphQL schema. And so you can actually take up a lot of time, and we've seen that.
And that's a great example of, what you can then actually do with the traces. Yes, it's great to look at an individual trace, right? Because you can see why did this particular request take so long. But I think if you look at this from a different perspective, if you have millions of traces, you can then do forensics by asking other questions. Hey, what are the queries where the validate is actually taking over proportionally long? And then you can say, hey, let's optimize these queries because the validate function is taking so long. Or as you also said, right, you can say which of my queries end up in parsing, or let's say querying too much data from the backend, the n+1 query problem, because you see more and more calls be made to the backend. So you can just say, show me those traces where you see a certain pattern. And then because you have the initial query that came in, you can say, this is the query that was leading to this behavior that we need to optimize. Yeah.
Exactly. It's absolutely mind-boggling the amount of information you can just start pulling out because all of this was added in.
Mm-hmm.
It has led to so many both where we would have errors. One thing that I'm not highlighting here, but I'm showing here how I named this rollout info query. One thing you may be wondering is, well, okay, that's great, but maybe this doesn't highlight red, or it doesn't do something when it's a bad query. Well, now because we have all of this information, I can actually make this turn into a highlighted issue if there are any errors on the errors piece of our response, because I can now actually look into that.
Yeah, I think
So
that's also the point that you brought up in the beginning, that everything by default is an HTTP 200 response, but you can look into the payload, and with OpenTelemetry can then set the error on that node. Yeah, that's fantastic.
Exactly. And then really just to dive into it, I know I showed this piece of code right here, but this was the initial piece that you saw. And I wanted to highlight this is all it took. This is our Express application being built up. But once this file was created, all I had to do was import that tracer. And I have a start function here just because of the way our import works, but that's all I needed to do. And now everything is just up and running, and OpenTelemetry is working.
Awesome.
So what's new? There's many things coming down the line for OpenTelemetry. I kind of hinted at it with the talk of how we've kind of looked at observability and really have changed our view on it. And OpenTelemetry has taken exactly that change as it keeps coming. So first, how can you contribute? How can you get help? Well, there's OpenTelemetry working groups. There's everything from the standards committee to specific language implementers to a specific functionality. So function as a service, there's a working group for that. JavaScript, working group. You can go into any one of these, and they're all highlighted on OpenTelemetry's website. And you can speed up some of these issues or speed up work on them, and you can contribute by either one, creating your own issues. I was helping out with OpenTelemetry for a while, and the first thing that would always become a thing is, well, if we don't have issues cropping up, we don't know that there's a problem. And so creating issues is the first step in getting the maintainers to kind of, and developers to look at it and be like, okay, there is an issue here. I can now start diving into it. And these don't just have to be bugs. These can also be something where you want an instrumented requested. Here you're seeing someone wants Keisley instrumented. And there's even things such as, hey, I want to add a new feature onto GraphQL because I notice you're not doing X thing. And so creating an issue for that then prioritizes it in the list, and a developer will work on it. And if you're feeling so inclined, you can also help implement the changes and do pull requests. That was one way I was helping out for a while, was actually bringing in, looking at issues that were coming in, trying to help out and create pull requests for those issues. I mean, it's a very welcoming committee. And while at times it can feel like there's a little bit of a loss of continuity, it's understandable because how fast OpenTelemetry is growing, they're also having to grow their standards and their committees around it. So any help is appreciated. So what features are coming out? On the right here, you saw before that list of languages and kind of where things were at. Well, here you go even more. The big three: traces, metrics, and logs. Logs just got solidified this last year, and so everyone's kind of building it into their main system. And you'll see here that A lot of them are quite developed. You'll see Java there. Traces metrics are stable, logs is an experimental. That means they got basically the main portion of development done, and now they're just working through it. You'll see others where they're not implemented yet. Ruby, they have the traces, they don't have metrics and logs. But really just look to that feature list because it will tell you. Another big feature that's coming down the line, the working group I think just got started this last year, late last year and into this year, is real user monitoring. This is a feature that I know the OTel group has been wanting to build out, and now that really the JavaScript side of things is kind of being broken up a little bit to make it easier to maintain, the real user monitoring group is really starting to get started and build out that piece of it. And finally, code profiling. Some people may not think that's, in your observability or telemetry platform, but I can't tell you how many times I've gone into a request or I've gone into something and actually wanted to look at, okay, a method ran, where in that method did something go wrong? And that's really, observability platforms are doing that, but OpenTelemetry is trying to turn that into an open source protocol. That just got started this year, so that'll be coming down the line. But it's just amazing that all of these things that were once very either tied into one specific observability platform or was something you had to custom make is really just coming out into an open standard. It's just been such a big boon for this area.
And I think, Justin, that's a great reminder, because some people may wonder, I thought, modern observability tools already do all of this. And yes, they do, as you said, right? Most tools, commercial tools do this, but now we have a standard that standardizes the way this type of information should be captured, what the protocol is, what data is captured. And this also benefits every observability vendor, including, Dynatrace, who I work for and that you're using, I know, because we will be able to benefit from all this data, these standards, because it helps us to broaden the scope of the technology we support without having to kind of always keep our own agent that does auto instrumentation always up to date with the latest technologies, because now instrumentation will be built into those runtimes, into those libraries, by default. I think that's great,
Exactly. I think I said it in the podcast, but it removes some of the what some may consider the boring work, and gets it to this open standard to let observability vendors work on some more cool things. We don't want to keep reinventing the wheel.
Exactly. Hey, Justin, thank you so much. I know this is the end of your presentation, but I wanted to just highlight, if you may want to just stop sharing the screen, so I have you in full screen actually in the recording. That would be perfect. Justin, thank you so much for doing this. To recap, what I learned today is OpenTelemetry is a great open source framework that is very popular, has become very popular, because by now also it makes it very easy for every developer to instrument their applications with a wide variety of technologies and runtimes and languages it already supports. In your particular use case, we looked at GraphQL, which is also a very popular framework, which makes it easy for anybody that wants to query some type of data from your system by executing a query against GraphQL, and then GraphQL figures out how to get this data. The challenge with this is, like with Hibernate that we referenced multiple times, a query can be very simple and efficient. A query can be very complex and spans out to many backend services, consuming a lot of resources, querying too much data, and therefore getting the observability into GraphQL helps us to identify bad actors, bad queries. It allows us to optimize our queries, detecting patterns like the N+1 query problem, the validates, the parsing. So I think this is a really great what you showed, that there's certain patterns we need to look for, and OpenTelemetry is an easy way to get this observability in GraphQL.
Exactly.
Cool. All right. With this, thank you so much. All of the relevant links that you showed today in the presentation will also be in the description of this video, wherever you watch it. And I can only echo, if you want to contribute, because open source makes it very easy to contribute, whether it is a bug, whether it's reviewing something, whether it's documentation, samples. all these platforms, all these projects are always looking for somebody that helps them.
Exactly.
All right. With this, thank you so much.
Thank you.
And see you next time. Bye-bye.